Okay. Pleasure to be here. So, the last speaker spoke a little bit about sleep and actigraphy. So, a nice segue to my talk. I won't be talking about actigraphy, but my title of my talk is the CHSQ key measure of sleep problems in Syngap 1. Now, my talk is outlined in two parts. So, thank you. I wasn't sure whether you could hear me or not. Is this better? Good, good. All right. Well, I'm glad you caught me early. All right. So I'll be talking about the CHSQ as a marker, a measure of sleep problems. And my talk is divided in two parts. So why study sleep? And then I'll be sharing some of our past and current data using the CHSQ. So all of us in this room have had challenges with sleep, whether it is that we're jet lagged or we are parents of individuals with sleep problems or we have sleep problems ourselves, right? But sleep is not just relegated to humans. In my cartoon here, we can see that sleep habits extend across the animal kingdom. The adult giraffe that is depicted here sleeps about 30 minutes in a 24-hour period. And they can go several weeks without a nap. And when they do nap, it's about 5 minutes. And I imagine that parents of Syngap may say, that sounds like my kid. But then the other extreme are the bats that sleep about 20 hours in a 24-hour period. So sleep is certainly conserved. And so it suggests that sleep may have some physiological role. We know that sleep is important for the regulation of multiple organ systems, including the brain, right? It plays important roles in synaptic plasticity and neurogenesis. And if you sleep well, right, your cognitive function is better, your adaptive function is better, your physical health is better, and your immune system is better. But when you sleep poorly, all of those things can be negatively affected. Sleep problems are not just common in adults, it's also common in children, and it's common in typically developing children, where 20 to 40% of typical developing children do have sleep problems. But sleep problems are certainly more prevalent, but also more severe in individuals with neurodevelopmental disabilities, with a prevalence of 40 to 80%. There are several ways that sleep problems can manifest in kiddos, certainly with insomnia. So it might be sleep onset or sleep maintenance insomnia, but it could also be sleep disordered breathing. In individuals with epilepsy and the genetic disorders of Rett and Fragile X, we see both a combination of insomnia and sleep disordered breathing. And in those with autism, there tends to be more insomnia. I'm not sure what's going on with my slides, but I'll move forward nonetheless. Global developmental delay, behavior, and sensory processing challenges are common in individuals with sleep disorder, with Syngap 1. So we see that in about 100% of individuals. And in an earlier paper from Vasclamp's group, we saw that intellectual disability, epilepsy, autism, and sleep have varying frequencies, with sleep being seen in about 62% of individuals. But in collaboration with SRF, we did a needs sleep assessment. And one of the first questions we asked was, does your child with Syngap 1 have sleep challenges? And we see that about 87% said yes. 9% said no, and 4% said, I don't know. And I don't know might just mean, my kiddo hasn't really shown sleep problems yet, so I don't know if they will or not. We asked, how important is it to manage sleep problems? And about 91% of parents reported that it was either extremely important or somewhat important. We asked, what type of sleep problems does your child have? And the common sleep problems were difficulty falling asleep, difficulty staying asleep, early morning arousal, and restless sleep. And so these all fall within the category of insomnia, right? In a earlier assessment that we did of a group of 19 individuals in our clinic, we asked parents to rank the impact of sleep on their quality of life. And we gave them 10 clinical features of Syngap 1. And what we've noted here is that about 62% of parents ranked sleep in the top 5 problems. And that was more than those parents who ranked epilepsy. So using the Children's Sleep Habits questionnaire to evaluate sleep in this population, the CHSQ is a parent-reported questionnaire. It assesses both behavioral and medical-based sleep problems. It's well validated for typical developing individuals between the ages of 4 and 10, but it's used extensively to evaluate sleep in individuals with neurodevelopmental disorders. A total score of greater than or equal to 41 is considered clinically significant, and it is broken down into 8 subscales. So the subscale scores sum to give the total score. The work that I'll be sharing is the earlier papers that our group published, in addition to some of the work that I'm going to share now, which is from the Simon Searchlight cohort. So in our 2021 Brain Sciences paper, we show that total sleep and all subscale sleep was higher. The scores were higher in individuals with Syngap 1, indicating that sleep problems were worse in that group as compared to typically developing siblings. And really encouraging for us, we saw a very similar pattern with our current cohort from the Simon Searchlight database, where total sleep scores, in addition to all subscale scores, were significantly higher in individuals with Syngap 1. Now, we wanted to know if there are predictors of sleep disturbance. And I'm sure you all know that Syngap is thought to be a high autism risk gene. So we asked the question, is autism a predictor of sleep disturbance? And what we found, certainly from our 2021 study, but also the current cohort, is that autism doesn't predict sleep disorder in this population, whether the total sleep score or any of the subscale scores. We also determined that age, sex are not a predictor of sleep disturbance in this population. But we wanted to know, since bedtime resistance is often such a challenge for parents, are there subscale scores that can predict bedtime resistance? And in our 2021 study, we showed that sleep anxiety is a predictor of bedtime resistance. And that was supported again in our current study using the Simon Searchlight cohort, where we see sleep anxiety being a strong predictor of bedtime resistance in this population. Now, early in my talk, I said that sleep plays an important role for cognition, adaptive function, and behavior. And so we asked the question, what is the relationship between sleep and behavior and adaptive function in our individuals with Syngap 1? And to answer that question, we used the CBCL, which is a parent-reported measure. It is used to detect both behavioral and emotional problems in children and adolescents. So the 2 to 5-year-old are the preschool, and the 6 to 18-year-old are the school age. There are 8 syndrome scales that are used to give us more insight into the DSM-5 oriented scales. So that's affective disorders. So we can think of depression or depressed mood would fall into that category. Anxiety, somatic disorders, ADHD, oppositional defiant, and conduct disorder. Now, the important thing to bear in mind is that a high score equals lower function. We also use the Vineland to evaluate adaptive function. And the Vineland is well validated in individuals with intellectual, developmental, and other disabilities. It's a parent-caregiver questionnaire, and it's validated for individuals from birth to age 99. There are three primary domains, so communication, daily living skill, and socialization. And what we're seeing here is that higher scores equal higher function. So we asked, what is the relationship between sleep and behavior? And this is in our preschool cohort. What you can see in the panels A through C is that higher scores on the depressed or affective disorder scale of the CBCL is predictive of a higher sleep disturbance score. So more depressive symptoms equal more sleep problems. And that, if we were to look more granularly at the subscale scores, we can see that higher depressive symptoms are predictive of problems with sleep duration and parasomnias. In panels D through E, what I'm showing you here is that higher scores on the anxiety disorder subscale, again, is predictive of higher scores on total sleep as well as bedtime resistance, so consistent with the earlier data that I showed you. And then in panels F through G, we're seeing that higher scores in the autism clinical features, again, strongly predictive of parasomnia and sleep disordered breathing. So when we looked at the 6 to 18 age group, so the school age group, what we're seeing here is that higher scores on conduct disorder predicts higher sleep anxiety, and a higher score on depression predicts parasomnias. We asked, are there bidirectional relationships as it relates to sleep and the adaptive function? And the adaptive function, we got that data from Vineland. And what we're showing here is that nighttime awakening, so this is a sleep score, when there's more nighttime awakening, individuals tend to have lower scores, so lower function on their socialization. And similarly, when there are higher nighttime awakening scores, individuals tend to have lower scores as it relates to their play skills, which is not surprising. When we ask the converse, which is how does social abilities predict sleep, what came out was that higher social functioning is associated with lower sleep scores as it relates to nighttime functioning, and higher scores on the coping. So coping is a measure of one's tolerance for behavioral challenges, so stressful situations. So individuals who are better able to cope with challenging situations tend to have better sleep, so lower scores on nighttime awakening. So what I'm sharing here is that there is a bidirectional relationship between sleep and adaptive function as it relates to socialization in this cohort. So in summary, I've shared that sleep problems are important to parents of children with Syngap 1. I've shared that in the two cohorts that we've looked at, the CHSQ is a reliable measure. It's a well-validated measure. It's clinically relevant because it tells us about issues that are important to parents, and it's actually a very easy scale to administer. What we yet have to determine is its responsiveness to change, and that will require some sort of intervention study. I've also shared that sleep anxiety is a strong predictor of bedtime resistance in the young and a predictor of conduct disorder in the older children, that there is a bidirectional relationship between sleep and adaptive function, that poor emotion and behavioral regulation predicts nighttime awakening, And altogether, I think this data suggests that perhaps managing anxiety and behavioral regulation may improve nighttime sleep. Some of the things that we have ongoing, we have some actigraphy work. We have published some, and we're working to submit a current paper. And we're also looking at sleep and in the context of EEGs. So with that, I want to thank certainly the children with and without Syngap 1 and their families who participated in this work, our team, and certainly Simon Searchlight, SRF, and other funding organizations.